doing my data viz on the typical Oscar-winning actress's career. It's a bit of a trip down memory lane. It's been a little while since I've done this last. So we're going to have a look through this, see what's going on with the viz. Vaguely remember what we're doing. I have an outline here just above me of what I'm anticipating doing with this work this time. But let's get back into it. Let me remind myself and you what we were all doing. So we're using Tableau to build a visualization of a dataset we are constructing using R. So what I'm going to do is I'm just going to get R to run this script. We've been working on this for some time, so I just want R to get all the script ready and prepared for me. So I'm going to load in my packages, and now the next section I remember was unzipping a lot of big files we had. We've already done that part, so we can just skip those. Just comment those out for future. And now we can just carry on down here. Okay, just before we write any files. Yeah, so that's going to go away, load all this data, do a lot of stuff. I'm going to leave that to run in the background just so we have all that ready and prepared for us. Now let's remember what we were building out in the visualization. So we're trying to see what the typical Oscar-winning actress's career looked like. And we're using IMDB, we're using the film ratings to say how good were the films they appeared in across the length of their career. So what we were doing was looking at the rating for that film versus the average rating for a film at that year. So did they appear in the better films of that year or the worst films of that year? And then we were running this on a sort of continual basis, a running total on this. So it's come up with some quite... Here looks typical. The idea of this is the typical looks very smooth and like, oh yes, you've just got to consistently work at being in better than average films throughout your career. When really, we look around some of these different lines here, it's all insane. It doesn't really matter to an extent. There was so many where I was thinking how many of them went and broke the rule in this case. So this is where we were starting to pass out some ones that actually, like if we were going to categorize these up, sort of severe, interesting careers where we can actually say they broke different rules. So these were ones that followed that kind of linear path of, yes, they consistently appeared in better and better films as time went on. We had a group here that real outliers because they had multiple Oscar wins that really changed things for them. Didn't quite know how to deal with them. We've been obviously struggling with these real outliers from the dataset, Betty Davis and Meryl Streep. They've appeared in so many films that it's just unreasonable amount of career with successful career like overarching in the data. It's really interesting to see. I'm putting these here until I have a better thing to do. So here we've got other ones. So there was a case that you always had to be. We were thinking about age in this case, whether you always had to be young to be an Oscar winner, and there was certainly a case where we could see there was two categories where, well, actually quite a few categories in terms of age restrictions. So there's some cases where you're an Oscar winner under the age of 25, and those careers have all gone remarkably different directions. Time was on, so like Jennifer Lawrence, very successful career into like mid-30s. Audrey Hepburn, very famous, but like Marley Matlin, don't know. Don't know where this has gone really compared to the others. So we're seeing some here where actually their careers were better off actually as they got older. If you like, they really came into their own in their 50s. So like, for example, Maggie Smith, if you've ever seen things like Downton Abbey, is fantastic actor for that kind of older lady character. Surely was probably very good in her youth, but yeah, you can't think of her in any other role at the moment. Here we have cases where actually they got the Oscar, but their career declined shortly after that, or soon after that. So some interesting cases here where you don't always have to, like for Jane Wyman, so you don't always have to appear in the good films to win the Oscar. So this, what I've tried to do here is highlight in black here where they got their Oscar, just so I could see it on the screen. We're going to change that around a little bit, but you can see here actually didn't appear in very good films throughout her 20s, but still was able to pick an Oscar up at the age of 31, which is pretty cool. These are ones that got, I have to check what this was. I think this was where the career was better when they were younger compared to like better when they're older. This would be, as I think there was like a median age we had back here that you had to be like early 30s, I believe, was where most actresses got their Oscar. So what's that? So later on, and then here we're talking about those that are over 45 that got their Oscar. So what I want to try and do is get this into like a map layers format where I can use visualise to work these lines out. Because what's happening at the moment is you can see some cases where I've tried to make the line thicker where they have more films, just to emphasize they've appeared in more films, because sometimes it's not very easy to understand. And it kind of leads into this effect we've got going on. So we're trying to build into this little effect I had, all with different film cans. So I had this idea of like a reel of film coming off out of a film can. So you would have, say, a can here, and then the spread of different actresses' career. This was sort of the visual metaphor I'm trying to lean into, so that when you're looking at it, depending how it's flexing, that will be like wider or thinner. So I wanted to lean into that. But you have cases here where something large is like 6 films in one case, and in other cases will be like quite small for others. So like here 8 versus 6. So we'll want to try and get this all into one sheet, so we can try and get this like looking very consistent, because you can notice that all these axes are completely different. So here it goes to 25, but here it goes to over 150, which is the Betty Davis effect, as I will call it. Hugely successful. So we've got these different categories. They're going to be like, from working in an archive, you arrange things in different groupings. So this was going to be like a layout of these different careers grouped by like categories. That's the plan anyway. That's the plan. We're just going to see how it goes. So we want to change these into the sort of ridgeline plot where it's not very, like, there will be a sort of degree of overlap. Like if I like each line plot. But yeah, so sort of like this. We're going to see how this looks in terms of that. So it'll probably look more like this, but just a line that gets thicker. Thicker or not. Actually, that one is behind my face. So yeah, I'll say something. Oh, damn it. So something like this, where it's kind of, yeah. I think it'll be alright. This is it. This part of it. I haven't really come in with an idea of how it's going to look at the end. It's just kind of evolved as we've gone along, when we've just been exploring the data and trying to make something very visually interesting come out the other side. So let's get to this. Okay, and yeah, oh yes, part of this was, now that we've worked out all these different categories from the analysis, we need to go and put those back into R to then, so we bring that data point in. So we know that these are all in the category that follow that generic path, that they were, they have followed that typical kind of career. But even here you can see like Ginger Rogers didn't start off too well, but it got better later on. So yeah, we got a bit of work to do. So I've got to go and now find out all these different categories we had and see where we are with our... I don't know what's gone on with my R studio these days. It's very like glitchy now and then. Okay, so I've got my code over here. I'm going to switch it around. So I can go and change the panes. So console on the right. Yeah. There we go. Should be all good. Yeah, it kind of does this glitch, like you can see it now and then. It's quite weird. What I'm going to do also is I'm going to just change my screen settings, because this shouldn't be like this. Yep. Alright, just hold on a second. I'm just going to go and change the size of this screen, just so you can actually see half the work I'm doing. I think it's this one. Just watches everything breaks. Ooh. Hold on. Keep those changes. Look at this, just like completely on the fly, fixing my computer. Let's make this a little bit bigger. There we go. So that kind of works. If I just go and make everything bigger again, there you might actually have a chance of seeing what I'm doing. There you go. That's not too bad. That's not too bad. Cool. Okay. What are we going to do? So, okay, I've got my R code. I just got to go back over what we were doing. So, okay. Yeah, so how we were working this was we were bringing in our different data sources for different actresses. So the names, titles of the ratings of the films, yeah, these kind of words. Yeah, we were then combining it with the actual Oscar data to see that they were an actress. Yes, they were an actress, and they were a winner. Voted for an actress, and that we wanted them to be an actress in the film, just in case there was any of those cases. I'm not 100% sure on that one, but we would then joining everything together. Filter, yep. Actresses. Then we would deduplicating any actresses, okay. So, yep. And then this is where I was trying to make out a little data set for the typical career. So if I go and have a look for this, if I can, typical career. Okay, 71 more rows. Oh, I hate that graphics. It's so annoying. Yeah, so this was age of filming, name rating. So this is the data set we were using for this, if I'm right. Yeah, so seeing that running total over those years. Okay. Right. And we're doing this division just to work out the average. Okay. So what I want to do is have a look at Oscar DF. Yeah, I remember this having quite a few columns, so we could do with cleaning it up a bit. God. Overall rating, category, winner. So if I go and say just once as data.frame. Okay. Okay, so this gives us an idea. God, I've got to clean this up. Okay, so yeah, so this was it. So Ingrid Beckman appeared in this film, Ocean Breakers, at the age of 20. It was rated 5.9. No, it was rated. Yeah, it was rated 5. Oh my god! 5.6, and that rating. The average film that year was rated 6.2, so it's like -1. I think it's -1 here. It's not the case there in Tableau, so if I go here and then rating score. Is this running total? Okay. So this, so this rates you, yeah, this is, because I remember I was playing about with this idea a few times, was it was saying if you were better than the average film, then 1 or -1. I remember I had done it where it was you had the difference as well. Which I can't remember why we changed. I don't know. Just gonna change it. Yeah, you don't need to. That it just, oh yeah, I remember, it makes it more dramatic, which I kind of like. This okay. Either way, we will carry on. We'll have a think about how we want to rate them at the end on these days. So okay, so these should be pretty typical kind of categories to make. So over 50, they won an Oscar. Okay, so in Tableau I made a calculate field called earliest Oscar age. Yeah, so we can start building these categories into our data set. So if I was to say group by go primary name. Primary name. Summarize. List Oscar. Zoom in of. Where's the age? Is adult starting here? I swear I had it in here. Age at filming, yeah. Oh, you can tell I've been doing SQL all day. Age at filming. Filter. Oscar. Was it Oscar or was it winner? Yeah, winner. Equals 1. It's a complaint. Oh, come on. Okay. Not sure why that's not working. Warning in min-age found. God damn it. Okay. Off to Stack Overflow as always. Oh no. Group by. Pretty sure I did that. Or maybe it's complaining because maybe earliest Oscar should be in quotes. One of the things I hate is doing strings in R is never great because it always gives you 2 ticks along the string, so it doesn't always work too well. Just do this bit. Oh, so that's the issue. So winner's not coming back. Do unique Oscar DF $winner. Okay, so it just comes back as true. As a quote. Okay, so it's saying, what was the age of filming? The minimum age of filming. I don't want that. Just want to know what the minimum age of filming was. Okay. There we go. Okay, so can we have, let's find Audrey Hepburn then. So Oscar under 25. Audrey Hepburn, yeah, 24. Okay, so that works. Can I give it a name? First, Oscar. Okay, no, are still being whatever it wants to be about that. Okay, cool. Call it here. Earliest Oscar. This. Okay. Yeah. So call it that, and I give it names. So basically changing the column headings. Primary name. Earliest Oscar. Nice. Okay, so that's good. What I also need to do is change this from primary name to that ID. It's in const. Change the in const. In const. So there's a case where they could have the same name. So if I use the ID field, that'd be better. But if I use I just use the ID field there just for checking purposes. Okay, so that one's done. So now we can work out who got. In this case is so we can work out who got the Oscar over 40, 25. What is? Okay, so here had one career declined. Rating up till Oscar age, and then rating up to the end of their career. Okay, so yeah, in this case, Joan Crawford's racing to here. So actually, you can see that Joan had a better career after the Oscar and then couldn't recover almost. Or case where their rating ended below 0 as well. Okay, so I've got a rating up to end of career. Let's see how these were made. Okay, so just doing that rating score sum. Okay, so I'm going to have both methods in my R script just so I can switch between the two if I want to later on. And I've got to go basically put that up, put that together. Okay. So what would be really helpful is joining these two together. So I'm going to do Oscar DF, do inner join Oscar DF, DF with Oscar by and const. Okay, I didn't do the names. Now we try it again. Yeah, that works. Okay, so you can see that one's come through as well. Oh my god, like, it's utterly awful. I don't know what's happened to this. Okay, so I've got my rating score here as well. Rename this plus minus 1 and making the one rating score difference. So the difference between the 2 years. Okay. Cool. So how am I going to do this? How am I going to do this again? So it was, so I got these scores. I'm going to do it to that Oscar year and then after that Oscar year. So I could start filtering the data by, so I could take Oscar DF and then filter, and I could filter age of filming. It's got to be less than earliest Oscar. Got to make sure I take the variable. I'm going to change this to earliest Oscar DF for data frame, just so there's no errors next time. Is that how I calculated? So, okay, so work out the age of filming. If that's greater than, yeah, if that's the Oscar year is greater than... Okay, so it's less than as or equal to. It's not equal to. So I want to filter those. I then want to summarize those two fields by nconst. Okay, it's quite similar to this. Const do this. So I want to summarize. -1. Let's give this a run. Okay, great. Nothing again. Is that the filters messing everything up? Okay, so this is now empty. Okay, cool, thank you. Okay, so I'm gonna have to go and rebuild Oscar DF. So where does that start? That's here. It's not too far. Okay, let's do it up till there. That works. So does this return anything? Yeah, so that works. That returns stuff. Okay, I'm happy with that. So what's the deal with this? Does this... Okay, that works. Okay, that works again. Cool. So we can check with Audrey Hepburn as well. Make this a bit wider. Okay, so Audrey Hepburn is -1 or... Okay, interesting. So you can have some where you can look... See, some of these are much better. So like Betty Davis did a lot of films, so the +1 may be giving him an advantage. Whereas this, you have -1 here, and then positive over here. So you appeared in a better film. So maybe you appeared in 3 films, 2 were good and 1 was bad. No, 2 were bad and 1 was very good in this case. So you get -1 here, but +1 here. Okay. Where's Audrey? She was... Yeah, so she was 1.8 there. So that's coming through, right? You can't give these names. This is ridiculous. They can't give these names. Okay, you can. What was I doing that was so wrong with that? I'm not going to answer that. I'm not going to answer that, but... rating... So of course rating up to Oscar. Oscar ±1. Move this onto a new line. Difference. So rating up to Oscar, and then we want to do rating after the Oscar. Okay, so yeah, that should be the same again. Let's have a look at this. Okay. So that works. I'm gonna change those back to nconst so I can go and join them to my data set. So rerun those. Cool. What? Why? Why does it do that? Okay. I'll do the same again. I'm just going to do 2 inner joins, join this together. Damn it, I should have renamed those. Oh, okay. Rating after Oscar. Rating after Oscar. Cool. And well, the nice thing is I can just rerun the code. Where are we? got those values. We then had something else. We had this option for in career declined, whether did their career end below 0. So I suppose I could just do this. So I could do total rating. Get rid of the filter. Goodbye that. Join that back in. That's good. That should now be so we've got those career ratings in them as well. There was something else about the 50s. So yeah, so there was, I think from this typical career was where you have 50 seems to be the age where you all just slow down with getting the good roles or appearing in the better films. So there was some of these that were better in the 50s. So better in the 50s. This is okay. So I did rating up to 50. Yeah, so I'm working out the growth to the age of 50, so take from the earliest film up to the age of 49 then. Okay, so the average growth, so for every year, so total career minus 50. Yeah, I think I'm working out like an average growth line. So the idea that if you were to draw a line here, okay, so if you do that one again, yeah, you can sort of see that this one's a bit close, but in a lot of these cases, say for like Maggie Smith, career really took off in her 50s. So do the same again. We will make a career up to 50. Rating up to 50. Filming less than 50. Okay. so have I got everything? I need the count of Oscars too. Oscars received as count. So you want to count winner? Okay, so you can't count. Maybe you can count Oscar. Let's have a look. Unique. Okay, so yeah, we'll just do a sum of Oscar. Nice, 3 Oscars. Okay, so total Oscars 1. Gonna add that in. Okay, now I should have everything I need to go and make these different categories in here. So names, DF. So I'm going to make these 2 different categories using the 2 different rating systems, and then we can work out how they're going to look. And a bit of a shame that I can't decide too much on this. Yeah, between these 2 different methods, but it'll be fine. Okay, I remember in R this is called as case, how you do like the case statement. I think it's like case switch. Case switch. Yeah, so case. Okay, so I can now make a category that accepts all these different cases using this case when. Call this analysis category. So case when. So when, in this case, Oscars received is greater than 1. Oscars received is greater than 1, then Oscars was then we had, so so we had the different years as well. So I need this analysis case to be on my different rating systems. So plus and minus 1. So when what Oscars, then we want the age band ones for when they received an Oscar. Over 45, under 25. So we want earliest Oscar. Earliest Oscar should be is it less than or equal to 25. Yeah, at least 25. Okay. And the other one is including, yeah. Okay. Okay, then equals 25, then call it Oscar at 25. This. That's all after 45. Okay, then we wanted this one about the career declining. Okay, so this is when up to the Oscar, your career was this, then afterwards what happened, yeah. So if, don't want to overwrite that one. So career rating plus minus 1. If that is greater than career rating plus or minus 1, change this, so plus or minus 1. So for the career rating was below 0 as well. So 0 then. Career declined. Okay, we got those. So was it better in the 50s? What's the next one? Which is a really hard calculation as well. I'm just gonna have to make sure I get this right. Okay, so we take Maggie Smith. I just want that value. Give me that give me that value. Get that value. Yes. Okay, so I've got that value. Do Oscar DF enter in const equals test. As data frame, so I can actually see it. If I could spell as well. Data frame test. This is rating up to 50 was this. Yeah, so it's based on when it starts, and then the graphics on this has been appalling. I'm gonna do a reinstall for next time. Okay, so we can work out here. So we need the minimum age of filming. Might need that as a column. So we had one for earliest Oscar here, so we can just do the same again, just make this for earliest film. And get rid of this. So let's go with this, earliest film. Okay, cool. Earliest film. Test. Oh, it doesn't come up. Okay, so this was, we were, so for test it was we're using 49 minus test earliest film. And rating up to 50. This will take you 25 years. So then this divided by bracket this thing. Oh, damn. Test. Okay, so every year Maggie Smith, add 0.225 to her rating. So that's your kind of growth line, and then we wanted to compare this to up to 50. You wanted the career total. This was like career. Minus that. Okay. So it's going to be from. So it's going to be from 50 max year minus 50. Okay, we can add that too. Last film DF. Nice, add that. Difference, test rating up to 50. Then we wanted test last film. Oh wow, okay, so what's this? Let's check this. Oh, okay, so we're not. Do it again. Okay, yeah, so you can see there's been better growth second half or after 50 than compared to leading up to 50 for Maggie Smith. Okay, right. So now I'm just going to put that into this thing here. Okay, so I want to know where this thing. Better than that thing. I'm just going to make this a column, call it better 50s. Okay, and then I need to change over the two rating systems, so plus minus 1. this is for difference, and that seems to be, the bar one seems fine. I just need to change the top one for ±1. And then we also need to change test. So if I find test and replace with Oscar DF, go replace. There we go, job done. Filter for Maggie again. And then call this as a data frame. So have I got that in the right way? So that's still saying, that's staying false. Test rate, so let's see what this is. Oh, it's right, but it's just, yeah, I needed to change the arrow around. So, yeah, so saying is the first bit greater than the second bit? And the answer is no, so I need to change that. Save that. Rerun that. Right, check for... yeah. Okay, yeah. That's still coming through, which is good. So now I can use this column here, career. That equals true. So career is better in the 50s. Okay, so what else do we have? Those that I say so career was better when under 50. Under 50. Oh, these are the ones that are currently, under the age of 50. This will be last film. Hello. Right, we're back. Okay, so just finishing this off. So we're finding those. This one was aged. Currently under 50. Cool. And then the rest was where they're following the path. Rest is we can keep rid of this, so I can now make this column. Spell. Okay, so it's going to be like that. Okay, there we go. So if I go and just keep adding to these. That works. So I'm just going to change this for the alternative version, the alternative calculating method. I'm going to call this difference. This to difference, this to difference. Difference and difference. Get rid of that, get rid of that. Okay, so let's go DF. Okay, that's done. I'm just going to write this to CSV. I'm going to give Tableau a refresh. Yeah. So we should have these categories, yeah, so these analysis categories are now coming in. Okay. Oh, that was much more hassle than I was hoping it to be, but it's done, which is the important thing. I am gonna stop things there. It's been a bit of a while getting back to this one, but so we've got our data sort of set and prep, so now we can start tackling some of these ridgeline plots and things like that in the next time. But yeah, join me in the next one. We will keep working through this. We will get to something at the end, and we'll decide on how we want to rate these different actresses, how Jones Crawford careers compares. But I still think these are very visually interesting. So anyway, I'm going to leave it there, and I will